Alrighty then, today, 8th grade at Schoenbar Middle School, we are going to learn how to solve a system by graphing. This is pretty much identical to the lesson that we had yesterday, so it shouldn't be too much of a difficulty, and it should be pretty easy. We should be able to blaze through it with no problems. And here we go. Consider the following. We have y is equal to x minus 4, and we have 2x minus 2y is equal to negative 2. The easiest way to solve a system of equations is by graphing. So what we're going to do is we're going to graph these two guys. So to graph them, the first thing we need to do is draw a set of axes. So we draw a horizontal axis that we're going to call the x-axis. Oh, that was horrible. The x-axis. Let's try that again, Mr. O'Neill. So we're going to draw one that's horizontal that we are going to call the x-axis. And then we're going to draw one that's vertical that we're going to call the y-axis. I'm going to redo that top one. Okay, so sorry my lines aren't straight. I wish I could draw straight lines, but I can't for some reason. And what we're going to do is we're going to start off by graphing them in color code. So the first one is going to be blue because it's already in blue. The second one I'm going to do is going to be in red. And we're going to do each one at a time. So let's start with blue. Blue starts in y is equal to mx plus b format. So we start off at negative 4. So 1, 2, 3, 4, make a dot. Our slope is 1. When you don't have anything in front of the number, we can always assume there's a 1 there. So a slope of 1 means I rise 1 and run 1. Rise 1 and run 1. Rise 1 and run 1. You can also drop 1, retreat 1. So you can go both ways. And then we just connect the dots as best we can. So there is my first graph. The second graph, on the other hand, is not in the standard y equals mx plus b format. So what we can do is we can use something called the cover-up method. What we would do is we would cover up one of the variables and see what we have left. So in this case, we have negative 2y is equal to negative 2. So going down, I would say, oops, wrong button. I would say, okay, I have negative 2y is equal to negative 2. Dividing both sides by negative 2, I get y equals 1. So I go to y equals 1 and make a dot. Then I would cover up, thank you. Then I would cover up the other variable and see what I have. Well, now I have 2x is equal to negative 2. So we would write down that 2x is equal to negative 2. Solving for x, we'd have x is equal to negative 1. So I go to negative 1 on the x-axis, and I make a dot. Now, do you see what the problem is going to be? Looking at these two graphs, what kind of a slope do we have? Are these ever going to intersect? The answer is no. These are parallel. Therefore, there is no solution. Now, why the book would start off with that, I don't know. But they do. And we can say, well, these aren't going to have a solution because they're parallel. That means they're never going to intersect. Give you another moment to finish writing this down. What they should have done for this lesson is started with something that's a little bit more accurate. They should have started with something more like y is equal to, let's start with, say, x minus 4. And y is equal to negative 2x. Yeah, just negative 2x. And see what happens with these two lines. So step 1 is, of course, draw a set of axes. Step 2 is to graph them one at a time. I'm going to color code these as pink and blue. Alright, so for pink we start off at negative 4. 1, 2, 3, 4. And it has a slope of 1. Might look familiar. And then for blue, it doesn't have a b value, so it starts at the origin at 0, 0. And it has a slope of negative 2, so I go down 2 over 1, down 2 over 1, down 2 over 1. And we have this situation. So if I look at it, it intersects right here, which is about right in the middle of the two. So I'd say the intersection would be at, what is that, 1.5? So like 1.5. And then vertically, negative 2.5. So in essence, we just graphed and saw where they intersect, just like yesterday's lesson. Let's go on to a third example. Hopefully this one will work out a little bit more nicely. Alright, we've got y is equal to 3x minus 5, and y is equal to negative 2x plus 1. So if we're going to solve the system by graphing, the first thing we would do is draw a set of axes. So here we go. Horizontal axis. Vertical axis. And from the looks of things, let's go ahead and go with purple and green. So for the purple one, I start off at -5. And I make a dot. Then the slope being 3 means I go up 3 into the right 1. So 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1.
Hello?
Hello?
Hi. Something happened. Yeah, something happened. We don't know what.
One of us got disconnected. Oh, really?
Really? I did not know that, man.
Yeah. That's
Well,
what
you guys are being extremely loud, so can you bring it down, please? Thank you. Okay, for how long were you guys disconnected for?
No clue.
Just a few minutes.
Like 5 minutes or something. 5 minutes? Not even less than, like, I said way less than that.
Okay, did you see this example?
Yes.
Yeah.
Yeah.
Okay.
You know, first part of what you're doing.
Okay. Do you see this example?
Yes.
Alright, so let's go ahead and go over this example. Okay, so for this example, we have 2 more. Now what we're going to do is we're going to graph each one separately. So for the first one, I said I was going to graph it in purple. And we start at -5 on the y-axis. So we start at -5 on the y-axis, way down here. Then we use the slope of 3 to find out where we're going. So slope of 3 means we go up 3 and then to the right 1. So we go up 3 to the right 1, up 3 to the right 1, up 3 to the right 1, up 1, 2, 3 to the right 1. So we make a dot right there. Then we connect the dots as straight as we possibly can. Oof, that's awful. Try that again, Mr. Neal. Okay, it kind of starts wobbling off to the side right there. So there. So it looks something like this. If I had a straight edge, this would look a lot better, but I don't have a straight edge, so we'll just have to live with what we've got. And then we go over to the green one. In the green one, we use the same method. We start off at 1, because that's our y-intercept. And then our slope is -2, which means that we go down 2, and then to the right 1. And then we go down 2, and to the right 1. And do I want this to be there? Actually, what I'm going to do is I'm going to redo this equation. I'm just going to make it -2x. That way our life is going to be a tiny bit easier. So I wanted to see them intersect at a perfect point. And if I start here at 0, 0, I go down 2 and to the right 1, what do we end up at? We ended up exactly where we wanted to be, right? Where do these 2 lines intersect at? Well, if I'm looking at it closely, I notice that I go over to the right 1 space. So that'd be right here. And then it looks like I had to go down 2, so that would be -2. So the intersection of these 2 lines would be at 1, comma, -2. So we've seen this 3 times. In the first example, we had 2 parallel lines that would never intersect, so that would be no solution. In the second, we had two lines that intersected kind of in the middle of nowhere, but we could estimate its value. And in this third one, we had two lines that intersected at a single point, and we know definitively what that point is. And that's basically the gist of all of the questions in 5-2, which is what we went over today. Is what we're going to do is we're going to graph the two lines and see where they intersect. So step 1, graph. Step 2, write down their intersection. Step 3, do something. And step 4, profit. All right, any questions about lesson 5-2? Judging by the lack of voices, I think you guys have this down, right?
Yes.
Think you can do some on your own?
Yes.
Well, let's find out. You know what classwork means, right?
Oh, yes.
It means it's to be done in class. And don't worry, I won't give you all of them. I'll just give you 1 through 15. So that's 15 really easy problems that you guys already know how to graph. If you don't know how to graph in the format that they're in, so for an example, if I saw something like, I don't know, 4x plus 8y is equal to 64. If I saw something like that and I didn't know how to graph it, I could convert it into the format that I do know by doing some careful manipulation. I would subtract 4x from both sides. And then I divide both sides by 8. And then I'd be able to graph it. Okay, so that is today's lesson. If you need to rewind it and go back over it again, it will be on Twitch, and I'll be uploading it to YouTube shortly. Good luck. Have fun.
You're kidding, right?